Hello, Takia.
Hello.
You're early today, huh? Takia, can you hear me?
Yeah, I can hear you. What you say?
You're early today.
I can hear you, Professor.
How are you?
Good evening, Professor.
How are you doing?
I'm good.
Okay, can you hear me? Takia.
Yeah, I can hear you.
All right, we are back. Let us finish what we have today from last week. As is left from last week, the binomial distribution. So that tomorrow we begin normal distribution. Before I start, does any of you have a question for me?
Yeah, you know we gotta talk, Professor.
How?
I said we have to talk.
We have to talk?
Yeah, I said we gotta talk
I
after.
feel like my life is falling apart.
Yes.
Hold on. Ask one after the other. Miss Ford, what do you say?
I said we gotta talk. You know, I'm coming back from my situation.
Yeah, we'll talk after the class.
All got up to you, Professor Hogan.
Hey, how are
Me
you?
too, because my life is falling apart.
Your life is falling apart. Well, I didn't do that.
Yes,
You did do this to me. You're doing this to me. You're ruining my life.
I'm always here to help. Miss Rita, can you mute yourself?
Yes.
All right. So, Miss Vista, I saw your email. I responded just a few minutes ago.
Really? Let me see. Let me see what you said.
Yeah, I said that test one. I'm gonna open it again, but this will be the last opening for it.
So, like, if
God bless you.
Thank
you. So I'm not ruining your life anymore, huh?
You gotta tell us when you opening it though. Like when you told me you was gonna give me the makeup work, I never even got it.
Oh, Miss Mache, you owe me something. I have not seen it yet.
Oh,
you know what I'm talking about, right?
Where is it? You sent it to me in the message. Yeah, but you didn't attach it to the message.
Yes, I did.
You did? Well, I'm gonna go back and double check because I just want my life to be together. So when you gonna open the test?
Today, I'm gonna open it again today.
Okay.
All right.
And what's gonna be the due date?
It's gonna be Sunday.
Okay.
That's why, because I don't want no more excuses.
Okay.
I don't know why it does that. Like,
it's not excuses. It's not excuses.
But when I open it again, I'm gonna make it 3 times. See if it allows you once. That means if you count it to the one that you already taken, that means you're making it 2 times. Okay. So I'm gonna open it, make it 3 times.
So like I did the first attempt, and then I was going in to do the second attempt. There was no retake button. I'm like, I was searching for it everywhere. There was no retake button.
I'm gonna open it again.
And my question for you is, Professor, so I told you that I took this class before, right? So it's other ways to solve this stuff besides Excel. And I don't use Excel, but like, why do we have to turn in Excel assignments if I solve it another way? Like when I'm doing the class limits, I just do it by hand. I don't do it with a formula. Like I just write it out. I know it's longer, but like I don't use Excel.
My share is not just this is the Excel is part of the assignment in the class. So I know you say you don't use it, but for this class you have to use it.
You have to use Excel.
Yeah, that assignment, yeah.
Okay. All right, I got you.
You don't have some home girls that might show you how to use Excel. Home girls, homeboys, you know what I mean? They can show
if
you
I
how
can
to
find my homegirls and my homeboys.
Yeah, they can show you how to use it. You know, they can do a lot of things. Young people can do a lot of things this day because they made unlike our own time when computer is so limited. Now it's everybody can have
Do
access.
you know Professor Brandon Myers?
Yeah, I know him.
Yeah, see, like when he didn't make us like he said you can use Excel if you wanted to, but it was optional. So like when we were learning the things, we didn't have to use Excel. So it's like I know how to do it without using it, but it's a part of your syllabus. So it's like I gotta learn how to
You
use
have
the
to be
Excel.
that part of it. Yeah, I want you to know it anyway. So that's why I put it there as part of this homework, because statistics, you cannot know it very well. If you know how to use Excel, to in addition to what you know, is a big advantage. You know,
Okay.
it will make your
Also,
life
like
better.
also Excel is not just used for statistics. Like you have to use it in the future, I guess.
Yeah,
For like,
Well,
exactly.
I use it at work every day. I just don't use
Oh,
it to
you use
put
it at work.
formulas
See?
in.
So you see what I'm talking about. Miss
Yeah,
Manche,
but I mean, I don't have to
I'll
use
pray for
it
you,
for
okay?
standard deviations and
Miss Manche,
probability.
I'm gonna pray for you, okay?
Please pray for me.
All right.
All right.
So you know what? Are you in the remind? So if you don't, if I send this thing to you like 2 weeks ago, so if you can't get it from BCC email, because some students say that when I attach something, they don't see it. So if you cannot see it in BCC email, I can attach it in Remind so that you can download it from there. So it's your phone. You
I
receive
gave
those
you the
messages.
number.
And
I'm sorry.
Do you receive
I
those messages?
gave-
No, not you, Bista. I'm talking to Mashir.
Okay, okay.
It's Mashir. Is your name on that? There's your phone in Remind. Do you receive those messages I sent through Remind? I think we lost her. Anyway,
Yeah,
let's start.
she's
Let's
not-
begin. We don't have much time, so let us start. Now, I told you last week that's, oh, hold on, let me delete this thing because there's something I want to delete so it won't clog up our screen. Yeah, let me delete this. Okay. Last week, there was a table I told you to download that we'll be using it from now on. So, and I uploaded that table here for you in the file section. It is called Statistical Table. So I'm going to download it now. Can everybody see my screen?
Yes.
Yes.
So
Yes.
please download this table and print it out. Use it, keep it handy. You'll be using it from now. It is right here, all the way to the end. So you can see right here, Statistical Table. You can see it. Can you see the link here?
Yeah.
So I'm gonna open it and then download it. We'll be using it from today. All right, got it. So back to the work we have today. Now, binomial distribution. Many probability experiments many problems that involves probability can have two outcomes, or we can reduce them to two outcomes. For example, I used coin and basketball game. You know, for coin, two outcomes, head or tail. Now, for basketball game, you know, it is a probability too, even though you can influence it if you have skilled players, but it's still a probability. That's why, you know, people have this sports betting. They bet on sports, who will win and which side will win, you know. So either this team win or they loses. When the baby is born, it's either a male or female. Blood pressure can be normal or not normal. So each of these have two outcomes: head or tail, win or no win, male or female, blood pressure high or low, or abnormal or abnormal. So all these scenarios are examples of binomial experiment. So a binomial experiment is a probability of experiments that have these properties here. The experiment is repeated for a fixed number of trials, where each trial is independent. And then there are only two possible outcomes. For example, in a dice, let me get my dice. Okay. See, this dice has 6 sides, okay? But if you are looking for 4 only, and you thought this dice, the outcome will be 2. Either 4 showed up or 4 did not show up. If you are looking for 6, then it's become a binomial experiment. Either a 6 showed up or a 6 did not show, and so on and so forth. So either there can be 2 outcomes or the outcome that can be reduced to 2. So independent, that means one outcome, the probability of one outcome happening have no effect on the other outcome. Okay, so independent trials. Then 2 possible outcomes. Then the probability of success is the same. For example, for a dice is 1/6. The probability of any of the outcomes 1/6. For a coin, it is 1.5. You know. Now, last property is this: the random variable x count the number of successful trials. We use x as a random variable for it. They count the number of successful trials. In this case, when the success doesn't mean on the positive side only, it can be on the negative side. It depends on what you are looking for. So now, if the outcome you're looking for is a 2 showing up, that means probability of success will be 2, and the failure will be 2 did not show up. You know, things like that. So look at some of the notation we use for binomial experiment. N represent the number of trials. PS, the probability of success in a single trial as a p, small p, and Q is the probability of failure, which we normally get by doing 1 minus p. And S represent the random variable, the count of the trial. No trial, 1 trial, 2 trials, 3 trials. So how many times for each trial? Now, when we start solving examples, you understand this better. Let's look at this example here. It says, decide whether this experiment is a binomial experiment. If it is, specify the values N, P, and Q. Look at this example here. It says, a certain surgical procedure has 85% chance of success. A doctor performed the procedure on 8 patients. The random variable represents the number of successful surgeries. So look at this. It has 2 outcomes. Either it is successful or it is not successful. That's number 1. So it passes the first requirement, which is 2 possible, second requirement, which is 2 possible outcomes. Now let's look at it again. It has a 5% chance of success. So that means our P. Remember, I said here that the probability of success is the same for each trial. So in this case, it is 85%, which is 0.85. Now, he performed it on 8 patients, which means that our N is 8. See, it passes the first requirement. The experiment is repeated for a fixed number of trials, where in this case is 8. So you can see everything here. N is 8, P is 0.85, Q is 1 minus P, which is 1 minus 0.85, which is 0.15. I can show you 1 minus 0.85, 1 minus 0.85, give you 0.15. Yeah. So you can see why it is a binomial experiment. It passes all the 4 tests. Then S, say for 8 patients, success, no, this one no success, 1 success, 2 successes, 3 all the way to the 8th patient. Any question for this? Any question, guys?
Nope.
All right. Now let's look at the second one. Say,
Can you go back 1 second?
Yeah.
So what's the difference between probability of success and number of successful surgeries?
What is the difference between?
The probability of success and number of successful surgeries. Like P equals X
The
equals.
probability of success is just it's just like the general probability that if you take this surgery, you have a 5% chance of no complication. Now,
Right.
number of success means how many have no complications.
Right.
Zero.
Right.
Okay? How many of them were successful? The first one, no successful. One successful. So all the way to the 8th. So this one will give you the general probability of success. This will give you the individual probabilities. Okay?
Yep, got it.
You got it?
Yep.
Okay. Now, look at this experiment. It says, decide whether this experiment is a binomial. And if it is, specify the N, P, and Q. A jar contains 5 red marbles, 9 red marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. Now, without replacement means that it is no longer independent. You see what I mean? And so it failed the first test, which is that they have to be independent. The experiment is repeated for a fixed number of trials where each trial is independent. So it failed, it's already failed one. Now, the other thing that it failed is this. Look at it. It says you have 5 red marbles, 9 blue marbles, and 6 green marbles. So the probability of each of these will not be the same. Remember, one of the requirements that the probability of success will be the same for all of them. Here it's not, because you have 5 red marbles, 9 red marbles. So because the marble is not repeated, the probability of success rate for each trial is no longer 5 or 2. Okay, that's where it is. This one disqualify it without replacement. So no, if once you have this first disqualification, no need to check the other one because it's no longer independent and it's no longer binomial. Okay. Now, which leads us to the formula for binomial. This is the formula we use to calculate the binomial probability. The probability of X is N combination X. If you remember this combination, when we are doing probability, we did NCX and NPX. You can get this part from the calculator. So N combination X times P to the power X times Q to the power N minus X, where N represents the number of trials, P, probability of success, Q, which is 1 minus P, probability of failure, and X is number of successes in N trials. Now, this formula might look like a monster, but once we start to use it, you will see that it is actually easy. Okay, I'm going to show you tonight. So let's see this example here. Are you ready?
Yeah.
Yes.
So the microfraction knee surgery has a 75% chance of success on patients with degenerative knees. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. Okay. So in this case, our probability of success is 75%, which is 0.75. You can see right here. Could be see, but okay, they put it as a fraction. You know, 3/4 is the same as 0.75. I'm going to show you what I mean by that. Excuse me. 3/4. 3/4. It's same. See, you can see it's here 0.75. In any case, I'm going to show you a more elaborate. Then we can go back. So in this case, N, sorry, it's big N. N equals, and then P equals, and then Q equals. Now, taking you back to that question, we have it here as the need surgery has a 5% chance of success on patients. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. So in this case, it was performed on how many patients? 3. See, 3 patients. So our N is 3. What is it? N is 3. So I'm going to make it small n because it is actually a small n. And then it says that it has what percentage of success?
75.
75, right? Okay. I think it's 75. Yes, 75. Okay, that means our P is 75%. So our P is 75%, which is 0.75. If you like, you can call it 3 or 4. Because 75 and 3 or 4 are the same thing. And then, so this is small p, not big P. And our Q, we get it by using the formula 1 minus P, 1 minus P, which is 1 minus P, which is 1 minus 0.75, and that gives us 0.25. So this is small q. Now, in this case, it is asking you to find the probability that the surgery, find the probability that the surgery being successful on exactly 2 patients. Exactly 2 patients. That means our X is 2. X equals 2. So we are looking for this probability. So this is formula here. If you remember the what they have on the screen, you can see the formula right here. P X equals N combination X times P to the power X times Q to the power N minus X. So in the question we are solving, anywhere you see N, you put 3. Anywhere you see X, you put 2. Anywhere you see N, of course, you put 3. Then for P, anywhere you see P, we put 0.75. Anywhere you see Q, you put 0.25. Don't worry about this part because we figure this out from the calculator, okay? Which give us, following that rule, we can plug it in here. You can see PX, P2 becomes equals, I'll make sure everybody's seeing this. Okay, you're all seeing this, right?
Yes.
Okay. So you're gonna be 3 combination 2 times, now this is combination, so you're gonna be like this, okay, times P is 0.75, 0.75 raised to the power X, and X is 2, times, this is raised to the power X, then times Q, which is 0.25, 0.25 raised to the power N minus X, which N is 3. That means 3 minus X is 2. Okay. So this would be 3 minus 2. So that is what they have in this section here. You can see right here. You can see right here. 3 combination 2 times 0.75 to the power 2. 3 over 4 means 0.75 times 1 over 4 raised to the power 3 minus 2. So that's what the same thing I have on that page. So let me write this down, and then we can calculate it. And you will see 3 combination 2 times 3 over 4. If you want, either or. If you want, you can use 0.75, or you can use 3 over 4. 3 over 4 raised to the power 2 times 1 over 4 raised to the power 3 minus 2. Okay. Now you can see, taking you to the calculator, you can see the combination right here. You can put the function to have combination 3 combination 2 3 comma 2, then you close the parenthesis, then times we have 3 over 4 squared, 3 over 4, which is 0.75, 0.75 squared, okay, times 0.25, okay, 3 minus 2 is 1, so it's raised to the power 1, raised to the power 1. Where's my 1? Because 3 minus 2 is 1. With 0.4218. 0.4218, which you can see here. 0.4218. If you round it up, you get 0.422. See, and which is what we also have here. 0.4218, which round up to 0.422. So it's something. Any question on this? Any question?
No.
So this is something we did. We can get it from using the table. By knowing that 0.3 over 4 is 0.75. N is 3. And Q, we don't need Q, just N, P, and X. X is 2. When you go to that table, which is here, so see the table binomial probability table. You can see it here. N is 3, and P is 0.75, which is right here, and S is 2. See, S is 2. N is S is 2. N is 3. And you go under 0.75. You can see it right here, 0.422. Can you see that?
Yeah, that's crazy.
I know. So so long as the P is right here, so long as you have your P here, you can always get it. It's the only way you cannot get it is if P is not there. Like if you say P is 0.61, 0.61 is not here, so that one you can see it here. But any of the P that are here, you can get it right here. Okay. Questions?
No.
Okay. Now, going back, let's look at
How will we recognize when to use it? How do we recognize when to use it? Like on the test question, what would the question say to give us the implication to use this particular formula?
Oh, if the question does not, if it doesn't say use table, then that means you're gonna use formula. But if it says use table,
If it don't say what?
don't say use table, use the binomial distribution table. That means if it doesn't say that, that means you're gonna use formula.
Okay.
So now, sometimes they can get. Oh, you know what? Remember the last time I was trying to draw a histogram, but it wasn't getting where I wasn't getting it right. So today I've solved that problem. I figured out a way to trick Excel. Anyway, you get the point. Look at it. It says binomial distribution. Let's list the possible values. This is binomial probability distribution. This one just lists us each of the values and their corresponding probabilities. So we call it the binomial probability distribution. Example, this one is given. N is P is 3, and P is 3 over 4. So you can ask you to get this. You just use the formula this way. We just did one of them and get for 2. See, if you want to get it for 3, we can go back. It is still the same. We're using the values from the same question here, but we solve for 2. to get 0.422. Let's solve for 1, for 0 and 1 and 3 using the binomial table. So for the binomial table, you can see n is 3. Let me make it a little bit bigger. Okay, n is 3, p is 0.75. We got for 2 already, 0.14. For 1, if you can follow it, you can see it right here, 0.016. See, 0.016. And when you go back there, you can see right there, 0.016. 0.016 for 0. And for 1, if you check it, same thing for 1, you see 7.75, n is 3, and x is 1. If you go follow it that way, you can see it's 0.141. So you can see right here. Otherwise, you can just use the formula to get it. See, 0.141. So following the same thing, we get this one. So this is probability distribution, the values and their corresponding probabilities. So either you use the table to get it or you use the Excel. I'm going to show you how you can get it using Excel. That one is even the easiest. So this question says, constructing binomial distribution. How do we construct it? It says in a survey, US adults were asked, were asked to give reasons, why they liked texting on their cellular phone. 7 adults, that means N is 7, who participated in the survey are randomly selected and asked whether they like texting because it is quicker than calling. Say, create a binomial probability distribution for the number of trials who responded yes. So that means there are 7 trials, I mean N is 7. And it says, if you look at the cell phone, you can see that we are asked if they like texting because it is quicker than calling. If you look at the results, you can see those that like texting quicker than calling. See? Say, why do you like texting? Say, quicker than calling. 56% of them, that means P is 0.56. Said yes to that, 0.56. And I want you to use that to create a binomial probability distribution. So you can see that P is 56%, N is 7, and Q is 0.14. How do we get Q? So let me simplify it here. We have okay. Yeah, I'm gonna draw a line here to demarcate it from here. Okay, N is 7. Okay, and P is, according to what we have here, 56% say they like it because they say yes, because it is quicker than calling. So we're gonna be 56%, 56%, 0.56%, or 0.56. Then and Q, Q will always be 1 minus P. What is it? Okay. Q is always 1 minus P. So our Q will be 1 minus P. So Q equals 1 minus P, which is 1 minus 0.56. Okay. Which this we can get from the calculator. 1 minus 0.56. Okay, we have 1 minus 0.56. Give me 0.44. So you can see right there, 0.44. 0.44. See? So that's how they get all these values that you see here in the.
Algebra, when this is college.
Huh? What's that? What's that?
Nothing.
Okay. So you can see 0.56 here, you can see 0.44. And it says 7 people were asked, right? 7 people, some adults. Those that did not say yes. Nobody say yes. 1 person say yes. 2 persons say yes. 3 said yes. 4 said yes. So you're going to find all these probabilities. For 0, you're going to be 7 combination 0 times 0.56 raised to the power 0 times 0.44 to the power 7 minus 0. 7 minus 0 is 0. I'm just using this formula. You're just plugging it into the formula, this formula here, which is n combination x times p to the power x times q to the power n minus x. That's why you say 7 minus 0. And 7 minus 0 is 7. See? So now let's plug this into the calculator. I'm going to show you how to simplify it for the 2 of them. Then we can now get the rest. We have right, 7 combination 0 times 0.56 to the power 0 times 0.44 to the power 7 minus 0, which is 7. So let me show you how to put this in the calculator. It's gonna be you have clear it. You have combination right here. 7, 0. We say 7 combination 0 times we have 0.56 to the power 0, 0.56 raised to the power 0, excuse me, 56 raised to the power 0, okay, then times 0.44, 0.44, okay, raised to the power 7 minus 0. 7 minus, yeah, okay, 7 minus 0 is 7 anyway. 7 minus 0 is 7. So 7 combination 0 times 0.56 to the power 0 times 0.44 to the power 7 minus 0, which is 7. You have 0.00319. So we stop at the third decimal places, which is 0.003. And when you go to that paper, you see it right there. 0.003, see? Now, next one is 7 combination 1. Write it down. 7 combination 1 times 0.56 to the power 1 times 0.44 to the power 7 minus 1. You can see that the p's are constant. 0.56 is constant for all of them. And 0.44 is constant for all of them. So that's why it's the probability of success is constant. So let's get this one. So you can now get, so you can have an idea of how it is can be obtained. So you have okay. So we have 7 combination 1, 7 combination 1 times 0.56 raised to the power 1, okay, times 0.44 raised to the power 7 minus 1 is 6, so raised to the power 6. Okay. Give you 0.028. Or if you like, you can say 0.0284. I can see it right there, 0.028. 0.028. So that's following that step, you get the rest of them to the 7th of them. Now, it says construct the probability distribution. This is the probability distribution right here. See, assume that you see the 0 for 0 we got this, and for 1 we got this one, which is 0.0284, and for 2 we got 0.1086. See, for 2 we get 0.1086. So why do they call it probability distribution? They call it probability distribution because it shows you the x values and their corresponding probabilities. Now, if you're asked to graph this, then let me show you how they can graph it. So this will help you to.
Hello, sir.
Yeah, go ahead.
Sorry to cut you short. Among all why did you choose 0.56 among all the you can go down a little, please. Down. Yes, why did you choose the 5, 6? You have like
because he said they were asked they're asked whether they like texting because it is quicker than calling.
Okay, yes, I see it now, quicker than calling.
Calling is 0.56.
Yeah. I was wondering why you chose the 5, 6.
Okay. Now, if you ask you to draw, assuming that this question asks you to draw the graph, all you have to do now is to put this in if you're using handwritten paper, like I showed you last week, if you're using a freehand drawing, you can use your pencil to make the S values and probability. But I since this is the age of technology, and let us just use Excel to do it. And this will help show you be an example of how you can use Excel to draw the graph that we are trying to draw last week with Excel, but I couldn't finish up. So I'm going to put this in Excel so that you can draw it faster and even more accurate. So I'm going to use X here, which is, what is it, 1 to 7, right? Let me see, 1 to 7. I think this is it right here. 3, 2, okay, I got it, 3, 2, okay. Let's 1 to 7 in Excel. 0, 1, 2, 3, 4, 5, 6, 7. I'm gonna make it a little bit bigger. Okay, now I'm gonna put this PX, which is the probability of X. Okay, 0.0032, 0.0284, okay, 0.1086, 0.2304, okay, 0.2932, 0.22, excuse me, 2239, okay, 0.0950, 0.0173. Now to draw it, I said, remember last week when we were drawing it, it wasn't giving us the exact that chart that we want. So there's a way I tricked Excel. You can trick some of these softwares to do what you want them to do. So I tricked it. I put dot here. I give us the same thing. Okay. That will fix the problem, no matter what version of Excel you are using. Okay. Okay.
What does the dot do?
Just to make it give you the chart you want. You know.
The what?
You will see what it do. You see what it does. Just give me 1 minute.
Okay.
Now, so you highlight it, insert, choose the chart you want to insert. I see it gave you the chart right away. Remember last week we were trying to get this, it wouldn't get us. Do you remember? Or do you forgot? Have you forgotten so fast?
No, we remember.
Don't break my heart. Okay. So you can see that it gave us the chart right away. What did I do? Okay. I'm trying to move it down. Then we can add the chart title. I think this is about those are number that say yes. Those that say yes. Okay. Let me add the answers. Okay. yes responses, yes responses. Yeah, probability. This is yes responses. And this is the probability of X. Probability which is PX. Okay. Now you can format this by format data series. I think this is blocking it. Let me move it to this side. See the gap. Start closing the gap. See, once the gap
like
is
a histogram.
Is a histogram. That's what we are looking for. So it will be closing the gap. And very fast. That's it. See, give it what you want. Now, if you don't put the dot, there's another way you can get around this. But this is the faster for me. If you don't put the dot, it will not give you the exact histogram you want. To give you something
Sorry,
else.
sir. How did you close? Where did you get the format plot that area?
You have to right click on any of the bars and then choose format. So if you right click on this, choose format data series, and then it will bring up that dialog box on this side. And then you can start closing the gaps. Okay?
Yes, thank you.
Welcome. So now go back to our work. So this is assuming that they ask you to draw the histogram. That's what you're gonna do. Let's do one more example here, and then we can then round up. So look at this example here. It says, I'm gonna use this example to show you how you can use technology for solving it. You can either use the formula, or I'm gonna show you both ways. It says here, the result of a recent survey indicates indicate that 67% of US adults consider air conditioning a necessity. If you randomly select 100 adults, what is the probability that exactly 7 adults consider air conditioning a necessity? Use technology to find the probability. Okay. So because this is a very large number, 75 adults, we can still get it. So, excuse me, N is 100, P is 0.67, and X is 0.75. So, I'm gonna give us, let me write them down. I'm gonna show you how you can use formula and then use the technology. N is 100, P is 67%, which is 0.67, and Q, we get Q by doing 1 minus P. And that will give you the Q. Then X, it says exactly 75. That means our X is 75. So what do we do? Let me show you how you can get it with formula. So you're gonna have, okay, yeah, close this one. So we have that our N equals 100. P equals, excuse me, 0.67%, which is 0.67, and Q equals 1 minus P, which is 1 minus 0.67. So with this, we can get from the calculator 1 minus 0.67. We have 1 minus 0.67 is 0.33. So you have 0.33. Okay. 0.33. then X is 75. So now remember the formula. Formula says it says PX equals N combination X, combination X times times P raised to the power X times Q raised to the power. Now let me raise this one to the power X. Raised to the power X times Q to the power raised. Huh?
I'm sorry. Taiji just texted me and she said her phone died. So just in case if she doesn't come back for the attendance, she was here.
Yeah, how many people are buying you as their lawyer, Miss? How much she paying you for this?
She's not paying me.
Legal fees. N minus X. See? So let's to the power N minus X. So I'm gonna put this M. That's how the formula is. So that means in that case, our N is 100. 100 combination X, which is 75. See the X is 75 times P, which is 0.67 raised to the power. So this is 100 combination. Okay, I'm gonna make it 100. 100 a combination 75 times P to the power X. Our X is 75 times this is P25 right here times Q to the power pure Q is 0.33 raised to the power N minus C N minus X. I mean it's 100 minus 75. So 100 minus 75. So we're gonna make it better. So we plug this into the calculator. Okay, so let's plug this in. I'm gonna put this, write it down on paper. 100 combination 75 times 0.67, okay, to the power 75 times 0.33 to the power 100 about 75. Okay, let's go and put it in the calculator, see what we got. Have okay, so you have hundreds, come on, 75, okay, times, in parentheses you have 0.67. Oh, excuse me, I missed it. 0.67 raised to the power 75. Okay. Times 0.33 raised to the power 100 minus 75 is 25. Am I right? Am I right or wrong?
You're right.
35.
That given 0.0210. 0.021 0201. 0201. So I'm gonna go and put it on the tax page. Okay. 0.0201. Now, when you look at that page, they use technology to do it, and then they get the same thing I got. You can see right here. Now, I've shown you how to do it with formula. Now, let me show you how you can do it with technology. The Excel. So I'm going to take you to Excel. Here. So I have what is it? I think I opened so many things. Okay, right here. I think this is it right here. So I'm gonna go down a little bit. These are N, P, Q, then X. Okay. Now our N is, so I'm gonna make this with N. Our N is 0.7, right? And P is 0.67. And we don't, do we need Q? I think we need Q. For Q, we're 0.3. I'm not sure we need Q. It's not necessary, I think. And our X is 75. So if you look at the command they use there, you see that the command is binom. See? Can you see it?
Yep.
Binom dist. Because when you go to Excel, it will give you different commands. Binom dist. So you can see that we don't need the PQ. So now, so we have this here. So the probability of X, we're looking for PX. Gives you equal binom. It will give you different forms of it. Use this one. Then it will give you numbers to click. The first one is number of this, all the X we're talking about, that's numbers, is the X. So you click on that, comma. You see where you have trials. How many trials? 100 trials. That's an N right there, comma. Then probability is 0.67, comma. And it give it cumulative. For cumulative, it gave you two options. True is for cumulative. False is for non-cumulative. Now, we're not looking for more than 75 or less than. We're looking for exactly 75. Only one of them. So we're gonna use the false, which present the.
Get all the way down to line 51, H51. Wasn't the example on A1 like in Excel?
What's that? Say.
In
Say
Excel, like on the other sheet, wasn't the formula in A1 and cell A1 the formula the by.
Are you talking about the one we are solving now or another one?
This one that we solving now. How did we get all the way down to H50, H51? I missed something.
Oh, page 50. Well, is
Like,
the,
how did we get to that area? How did we get to cell? I thought we was at A1. We'll put the formula in.
okay? You're talking about this line, right?
Yeah.
So you have to type the command. Just type, if you type the command, put equal sign and type binom. See that?
Oh, okay.
Then you choose the binom this right here. You mean binomial distribution. Then the numbers, that's the X, comma. The trials, how many trials? 100 of them, that's an N right there. The probabilities is 0.67. We don't need Q. Then for this cumulative, it gives you two. If it's a cumulative function you're looking for, like for example, if you're asking more than 75 or less than 75, then you can use the true. But we are looking for exactly 75. So we're gonna use the probability mass function, which is the false. Okay. So you can type false. I mean, we're using the mass function. That will give us the answer right here. Once you do it and press the enter key, it will give you the answer right there. Yeah. There's another way you can do it, but if we have more time, I can show you that one. But this is if you have exactly that amount, then you can do it that way. Any questions? Any question?
That false part, Did you write the false part or is it a
Yeah,
formula?
I typed in. I tried to click it. It didn't work, so I typed it in.
Okay. So false is a formula, pretty much.
Yeah, it's just part of the formula when it is you are looking for exactly a number.
Okay.
Let's see. Next one will be finishing up, rounding up. We look for let's see. An example. Well, I've shown you how to use tables, so we're not going to waste time on that one. So graphing. I have done one graph for you on that binomial. We did the graphing already. I'll show you how to graph it. So now let's look at the mean, variance, and standard deviation of a probability distribution. But before that, I think I can show you something else. You say, I think one. I'm looking for it. Say, so look at this one. He said, a survey indicates that 41% of women in the US consider their favorite leisure time activity. Consider reading their favorite leisure time activity. Now, he said you randomly select 4 US women and ask them if reading is their favorite activity. Find the probability of that at least 2 of them responded yes. At least 2. So I'm going to show you how to do this faster. So in this case, how many women you selected? You select 4 of them. So N is 4. Excuse me, my mistake. N is 4. So I'm going to do it right here. N is 4. Sorry, my mistake. What is the name? Okay, right here. So I'm going to draw this line so that you can demarcate this. N is 4. Okay. Then next is it says a survey indicates that 41% of women in US consider reading their favorite leisure activity time. Okay. So P is 41%. So our P is 41%. So P equals 41%, 0.41. And then Q equals 1 minus P, which is 1 minus 0.41, which is, we can do this in the calculator, 1 minus 0.41, 1 minus 0.41. 1 minus 0.41, 0.59, so 0.59, 0.59, 0.59. Then it's asking you the probability that at least 2 of them, that means 2 or more. That means you need probability of 2 plus P of 3 and P of 4, then add the answers. So they're looking for you say at least 2 of them said yes, which means that our X will be 2, 3, 4, and 4. That means you're going to find the probability of 2, find the probability of 3, and probability of 4 using the formula. That will take a long time. Excuse me. So the quickest way to do this is that, so you got probability of at least P of at least. Excuse me. 2 will be to find probability of 2 plus probability of 3 plus probability of 4. Now, This one, you cannot find it on the table because we don't have P.59 in the table. So the only way you can do this is either you use formula to find this probability, use formula to find this probability, then use formula to find this one, and then add them all. That's a lot of work. So what you're gonna do is we're gonna use Excel to get it faster. Let me write this down. N is 4, P is 0.41, Q is 0.59, and X is 2, 3, and 4. So we're going to use it to get the probability of each of them and add it. Then we can put the answers here in Excel. I'm going to put Pn equals, N is 4. Then P, okay, equals 0.4, right? 0.41. And Q, I'm not sure we need Q, equals 0.59. So now for our x's, we can use our x's here. X. Our x. We need let's get all the x's all the way to 4. Then we add want to add 0, 1, 2, 3, 4. Sorry, 4, 5. Well, 4. It stopped at 4. So I think I moved them too close. I'm going to move it back here. Okay. So I'm gonna delete this. Okay, let's get it done. So you're gonna do equals binom dot this binom. This time we're gonna use binom dot dist. This one here. So x's is 0. But you know what?
Why would you use that one? Because we're trying to find at least.
Yes.
Okay.
So let's get this binom dot this binom dot this. So we got so we're gonna get all of them. Then we can now add what we want to add. Number of trials is 0. Yeah, let's start. This is the first one. If you do the first one, they can copy it down. It calculate the rest for us. Then trials, n is 4, type 4, comma. The probability is 0.41, right? 0.41, 41, comma. Then cumulative, just use false because we're looking for individual before we can add. Then press the enter key. Hope you can see this. You all can see this, right?
Yep.
Yes.
You can copy it down. It will calculate the rest of them. Now, what we're looking for is probability of at least 2. So I'm gonna make it so you can see at least 2 equal. Remember, when I say at least 2, and the handout I told you that it's gonna be probability of 2 plus that of 3 and that of 4. So we're gonna add them here. You're gonna equal sum of this. For 2 we have this, plus for 3 we have this, plus for 4 we have this one. Enter key. Your 0.542. And you can see it right there.
Can you click on that? I want to see the formula.
You can see 0.542 right here. Hold on 1 minute.
Okay, never mind. It's the sum.
Yeah. So I'm gonna go back and click. So they click on the answer, right? Here,
Yeah.
right? You can see that here. Sum.
I got you.
Okay, 2, 3, 4. Because at least 2 is 2, 3, 4. That'll give you right away.
At the end, the cumulative answer.
Say it again.
I said, was the number that you calculated at the end, was that the answer, the cumulative?
Yeah, that's the final answer. Yeah, this one here.
That's the final answer right there.
Mm-hmm.
Okay.
Somebody's having fun here, right?
Mhm.
Can you show the formula for the zero, the one that you put in and you dragged it down for everyone, for all the remainders?
Once you put it right, you can drag it down to many numbers. It will calculate it for all of them.
Right. So what was that? I just want to know what the formula was. I didn't catch the bottom
Right
part.
here, binom dot dist. This is how you got dot dist. Then the first one is 0. Then the for the trials, you got to type it in. Four women were selected, and for the probability, type it in 0.41. Then type false. Then enter key to give it to you. Then copy it down.
Okay. Thank you.
Welcome. So now let us round up by doing the mean, the easiest part. Mean, median, variance and standard deviation of a binomial distribution. This one is easy. The mean is n times p as the formula. Okay. The variance is n times p times q, and the standard deviation is square root of n times p times q. Let's do this example. It says here, in Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. Find the mean, variance, and standard deviation of the number of cloudy days during the month of June. Interpret the results. So the n is 30. As the month of June have 30 days. P is 0.56 and Q is, 0.44. Let me write them down. N is 30. P is 0.56. Q is 0.44. Okay. Now, how do we get 0.44 for Q? It's just 1 minus P. 1 minus 0.56 give us that.
Can you slide up to that page one more time for me, please?
Can I do what? Can I do what? Say it again.
Slide up to that page that's over top of this example one time, please.
This one?
Yeah.
This one? Oh, you have this already in the file section.
I know. I'm just a note taker. Let me just write it down right fast. I'm done.
Good.
Okay.
So in that case, mean is n times p, which is 30 times 0.56. So you gotta be 30 times 0.56, 16.8. You can see right there. 16.8. See, the variance is n times p times q. It means 30 times 0.56 times 0.44. That will give you 77.4. Now you can verify it with your own calculator. The standard deviation will be the square root of that. It is always the square root of the variance. So the variance is 7.4. So the standard deviation will be square root of 7.4. Square root of 7.4. Square root of 7.4. 2.72. Basically 2.72. And that's what they have here. 2.72, which approximate to 2.7. So this means that on average, there are 16.8 cloudy days during the month of June. Any question before we end and go? Any question for me?
Can I see the question again?
Sure. Today is 7/26, right? 26. Mm-hmm. 7/26, 21. So now, since there's no more question, let me take your names so you can leave. I got this Johnson.
This slideshow is underneath, is in the file section.
Yeah, the file section, yes.
Okay.
That's Bista here. I got Dolly. Okay. Walker.
Here.
Next is error. Machine.
Okay, I'm about to leave. You gonna remember to open the test back up?
Yeah, well.
All right, thank you so much.
So, Miss Michelle, is your name in the remind? Do you get message from remind?
You say, is my name where?
Mine. When I send the message, does it receive it? Do you get it as text in your phone?
Yeah, I'm gonna look in the message now because I didn't see an attachment, so I'm gonna go back to it.
I didn't send it in the text message. I sent it to your email, to your BCC email.
Yeah,
So,
that's what I'm saying. I'm gonna go back and look at my messages on the Canvas to see if it's there.
it should be there. So let me know because it's been there for a while.
All right, I'm about to go look now, and I'll email you and let you know. I just email you when it's done.
But then Debbie. Okay, who and who? Takia Docket.
Hi, before anything, did you give the access to test 1 already?
No, not yet. After this class, I will put it there.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9. One person is missing. What's the name of the student that her phone died? Taiji, right?
Yeah, Taiji.
All right. I see you tomorrow.
Okay, see you.
If okay, Miss Ford.
Yes.
Have you finished what I gave you to finish for me?
Yeah, I put it in homework 2 because that's what it said in the message.
Homework 2. Okay, very good. Very good. Very good. I'm gonna send you the next one tonight.
Okay.
All right. Was that the question you want to ask me?
I guess I was gonna ask you about the test because I heard you say our class will be ending soon.
Yeah. I'll give you the test and I will let you know.
Okay. All right. And when our class end, like my girlfriend them trying to take me on vacation. They say I worked hard these last 2 years. So they said they're not going to take me until after my class is over with.
Well, I have no control over that one. I think this class ends in 13th.
The 13th?
Of August. Hold on, let me make sure. Hold on. Let me be sure.
Because there's some dates in there and days, and I was looking, I was like, wait a minute, this stuff say June.
Yeah, I think this class, hold on, let me see. The syllabus should say when it ends. Yeah. What syllabus? What is my syllabus? Yeah, right here. Yeah.
And we got a whole mess because my brother, he left a 11-year-old. So now we got to figure out what we going to do and who going to take the baby. I'm like, Lord have mercy.
Last day of class is, can you see the screen?
Uh-huh.
The last day of class is right here, August 12th. And the final exam will be August 13th. After that, I have no more use for you.
You gonna send it to me?
What do you want me to say, Mr. Luther? What do you want me to say?
Whatever you want to send me to help me. I'm like a basket case. I'm really up. I was listening. Oh, let me show you this too. Because I think this is the wrong calculator. Wait a minute. Let me see. How can I Lord, I can't see nothing. Let me find my glasses. Can you see this calculator?
Yeah, I think I can. It's good.
This one good?
Yeah, you just have to find the manual on how to use it.
I don't know. I guess can I go online and find it?
You can see it online. If you want to find it online, how to use it, you're gonna type the name of the calculator. I think this is
Okay, this is
TI
T.
31, right? 30, right?
This a TI 30XA.
Yeah, that's what you're gonna look for in YouTube.
Dr. Daniels, I think told us to get this. I still don't know how to use the damn thing.
Then why not use the Desmos, the one I use in the class?
Okay, you can use that one on the test.
Yeah, you just gotta go in, type in Desmos.com/scientific. Let me see if I can show you right here.
Okay, I've seen you do it before.
Okay. You can use that one. That one is free.
All right, because I say, Lord Jesus, they DESMO. Desmo.
So you gotta do Desmos here .com, then / then scientific. It's free. It's free of charge. Anybody can use it.
Okay.
All right. All right, Miss Ford, let you go.
All right. Thank you so much, Professor. I'll be looking for that email.
Yeah, I'm gonna send it.
Okay. Thank you.
You're welcome.
All right.